I'm going to solve the problem 310. It's about the system of forces. Actually, we're going to find the moment about point D at this problem. We know that the force of the rope or the string between E and C is unknown, but we know the moment of the force about point D is 960 Newton meter. So it's about D. We're going to find the force at AC. The distance D is 2.8. The first thing we need to know is to draw the triangle here and find the angle theta. I draw the right triangle ECQ. It's a right triangle here. EQ is 3 meter and CQ is 0.875. Tan theta is 0.875 over 3, and accordingly theta is 16.26 degree. Then we have the force in EC. I call it T. So T, I show it here. So T has two components, Tx and Ty. Actually, the angle theta is the angle between T and the horizontal line, so it's equal to theta. Obviously, Tx is T cosine theta and Ty is equal to T sine theta. So we know that the moment of T about point D is equal to 960 Newton meter. So I write here moment about point D is 960 Newton meter. Let's think about the forces which make the moment about point D. We have two components here, Tx and Ty. First, look at Tx. Tx is along line ED. Actually, there is no distance between the extension of Tx and the extension of line ED. Actually, they are in the same direction and the same extension, and obviously there is no arm. Moment is always force times the perpendicular distance, or the what we call it R. So here arm is 0, so Tx doesn't produce any moment about point D. So let's think about Ty. Ty here is at the distance of 2.8 meter at D, and it's perpendicular to line ED. So actually we have the if we think about the definition of moment, it's force times the distance from the force applied to the point we're calculating. So it's ED, distance ED times Ty. So from here we know that M about D is 960 Newton meter, and it's actually equal to Ty times 2.8 meter. So Ty, it's equal to 960 over 2.8, and we know that Ty is equal to T sine theta. So it's equal to 960 over 2.8. So T, the tension in the rope, is 960 over 2.8 sine 16.26. If we do the calculation here, we will have T equal 1244.5 Newton.